Welcome. In this video we're going to solve another past paper question involving differentiation. So the credit goes to Cambridge, and you check my website explainingmaths.com for all my other free resources, including many videos about differentiation. So what's going on? I see some sort of triangle here and a rectangle on the inside. And it says the diagram shows the cross-section of a hollow cone. Okay, so that is actually a cone, and a circular cylinder. Okay, and that's the cross-section. So they just took a knife and they cut a cross-section. The cone has a radius of 6, as you can see, and the height is 12. And the cylinder has a radius of r, and the height is h centimeters. Great. The cylinder just fits inside the cone with all its upper edges touching the surface of the cone. Okay, so that cylinder fits exactly inside. The question: express h in terms of r and hence show that the volume V of the cylinder is given by 12 pi r squared minus 2 pi r cubed. So that's quite some information, and what are we supposed to do? First of all, express h in terms of r. So we need to make some sort of equation which is going to say h equals and then something including a letter r. So 1h equals something with an r. And hence, using that information, show that the volume of the cylinder is given by this particular equation. Okay. Now let's see what's going on. Sometimes with these types of questions, they give you a surface area which you have to use, or they give you a volume which you can use, but now they don't give either. However, for this question you have to look at similarity, because the larger, I'll just call it a triangle rather than a cone, the larger triangle is mathematically similar to the smaller triangle. So what does that mean in terms of the mass? Is that if you look at the height of the larger triangle divided by its radius, that is going to be the same as the height of the smaller triangle divided by his or her radius. Okay, so the height of the larger one, 12, divided by the radius of the larger one, 6, equals, and then the height of the smaller triangle. What is the height here? Well, that's going to be 12, take away h, then you have that part left. So that is going to be 12 minus h over the radius, which is r. There we go. And now we are going to rearrange it. So it's going to say h equals and then the rest. Well, there's several things you can do. You could cross multiply now. You can also say, first of all, well, 12 divided by 6 is 2 equals 12 minus h over r. Multiply both sides by r. So 2r equals 12 minus h. And I'm going to move the minus h to the other side, so it becomes positive equals 12 minus 2r. Fantastic. So that is the equation expressing h in terms of r. There we go, because we have this term with the variable r. Moving on, they say, and hence show that the volume of the cylinder, so of this cylinder, is given by that particular equation. And to show that question means this is the answer, but we cannot use it in our workings. Okay, so we have to somehow find the volume of the cylinder, and then our answer should be 12 pi r squared minus 2 pi r cubed. Well, the volume of any cylinder is pi r squared times the height. You need to know that formula. It is the cross-sectional area times the height. And we have just said that the height is the same as 12 minus 2r. So let's see what happens if we say pi r squared times 12 minus 2r. So we're going to expand those brackets. Pi r squared times 12 is 12 pi r squared. And pi r squared times minus 2r is minus 2 pi r cubed. And then if you compare this equation with that one, you notice it's exactly the same. So I've shown that. So that's the answer. Put a v in front of it. And if you want, you can say QED. And you can look up on the internet what that exactly means. Fantastic. Moving on to part II. Given that r varies, so the length of that radius can change, find the stationary value of v. Now, a stationary value, if you start by writing that the stationary value is where the derivative dy dx equals 0. You get your first point if you just write that down. Stationary value is where the gradient is 0, dy dx is 0. Fantastic. getting some more points in, let's find that gradient function. Let's find the derivative of v. So we look at the first term, 12 pi r squared. So it's 2 times 12 pi. So that is 24 pi. And then the index of r squared decreases by 1. So it becomes r to the power 1. Yeah, so just r. Second term, 3 times minus 2 pi. So it's going to be minus 6 pi r to the power 2, because finding the derivative, that index decreases by 1. And then we say, well, to find a stationary point, that has to be a 0, so equals 0. And now we're going to solve it. We're going to find out what is the value of r for that to be 0. Again, several ways to approach it. I'm going to simplify it because I see common factors. I'm going to divide everything by 6 pi. Yeah, so this becomes minus r squared. 24 pi r divided by 6 pi is going to be 4r equals 0. Okay, that looks a lot easier to solve than that one. We can factorize now, take out the common factor, r, 4 minus r equals 0. And then r is either 0 or 4 minus r is 0, so r equals 4. So I get two values for r, 0 and 4. However, the question says find the stationary value of v. So clearly indicating you are going to get one answer. And then you need to realize, yeah, okay, we get two answers for r. But considering this is a practical situation, we have to get rid of that r equals 0, because the radius cannot be 0, because then you will have nothing. Or if you would have gotten a negative answer, you also have to cancel any negative answer. So the radius is 4, then you have a stationary value for the volume. The question is, find that stationary value of the volume. So the last thing we have to do, and I'll just squeeze it in over here, we have to find that volume when r is 4. So 12 pi times 4 squared minus 2 pi times 4 to the power of 3. And if you plug it in your calculator properly, you're going to get 64 pi, which is, to three significant figures, 201 centimeters cubed. Is it? Yes. Okay, I hope that was useful, guys. Like and share if it was, and check my website explainingmaths.com for all my free resources, including many more about differentiation. Take care. Bye-bye.